For any help regarding data analysis exam help, visit https://www.statisticsexamhelp.com. Email support@statisticsassignmenthelp.com/or. Call us at +1 678 648 4277. Data Analysis Exam Help. Sometimes we may want to generate two correlated random variables for stochastic simulation applications. For example, the duration and intensity of rainstorm may be highly uncertain but positively correlated. One option for generating correlated variables x and y is to obtain y from y equals x plus b, where x and are independent random variables with means equal to 0.0 and variance is equal to 1.0, and a and b are specified constants. A. What are the mean and variance of y? Expressed as functions of a and b solution, y equals x plus b equals ae x plus b equals 0 var y equals var x plus b equals a 2 var x plus b 2 var equals a 2 plus b 2b. Select a and b so that y has a variance of 2 and the correlation between x and y is 0.5. Show all relevant calculations. Solution. statisticsexamhelp.com. A 2 plus b2 equals 2 correl x y equals 0.5 equals COV x y /std x std y COV x y equals x x y y equals a x x plus b. So COV x y equals a x x 2 plus b x x equals a var x equals a is equal to 0.5 times 2 equals 0.707, b equals 1.22. Problem 2. Suppose that the time between failures of a structural component is modeled as an exponentially distributed random variable. You want to use the 10% quantile x10, defined by fx x10 equals 0.10, as an indication of how often the component should be tested. You have the following 10 recorded times between failures in HRS 512 1464 4995 7216 1150 27 17 78 42 39898 1967 8103. Propose a technique for estimating x10 from the observed times between failures. Solution. One technique is to use the exponential CDF to obtain x10 estimates using mx estimates from the data. statisticsexamhelp.com. Fx equals 1 exp x/a, where mx approximates a, and fx equals 0.1x10 equals 0.1054 mx. This estimator is both unbiased and consistent. Estimators that were not unbiased and consistent were also given credit, since the problem does not specify that they should be, but only estimators that actually estimate x10 legitimately were given full credit. B. Compute an x10 estimate from the above data. Solution. x10 equals 0.1054 times 7586 is equal to 799.6 c. Use the above data to derive a 99% large sample double-sided confidence interval for the true x10 value. You may wish to use the unit normal CDF plot provided at the end of this quiz. Solution. Because the estimator in this case is x10 and not mx, the approximation SD, a, SD, x/n cannot be used. For the above estimator, SD, x10, 0.1054 SD, x/n equals 390. For the 99% confidence interval is. statisticsexamhelp.com. -2.575, 799.6 x 10 slash 390.4 less than 2.575 205.7 x 10 less than 1804.9. Problem 3. Suppose that you have reason to believe that fluctuations x around the long-term average tidal velocity normal to a shoreline are uniformly distributed between a and plus a, with a mean of 0. The distributional parameter a, the upper limit on the velocity, is unknown. You have n velocity measurements, x1, x2, xn, which you assume is a random sample drawn from the postulated uniform distribution. In this problem, you will use the method of moments to estimate a from the random sample. A. Derive an expression that relates the variance of x to the parameter a. Solution. For this uniform CDF, var x equals 2a 2/12, this can be derived by integration. So var x equals a 2/3. B. Use this expression to suggest an estimator a, x1, x2, xn for a. Do you think your estimator is unbiased and consistent? You do not need to prove that these properties apply, just state your opinion, with justification. statisticsexamhelp.com. X. This is unbiased and consistent since S2 is an unbiased estimator of var x, and the variance of a approaches 0 as n approaches infinity. C. Describe how you would derive a two-sided large sample confidence interval for a from I, a specified confidence level 1, 2, an actual estimate a of a computed from the n velocity measurements with your suggested estimator, and 3, the standard deviation of a. Describe your procedure step by step so it could be carried out with a real dataset. Solution. Using this expression, as the problem states, a good estimator is a3sx of a. Describe your procedure step by step so it could be carried out with a real dataset. Solution. 3sx sd, a, f-1, 1 alpha/2, a less than 3sx sd, a, f-1, alpha/2, where f-1 is the inverse of the unit normal CDF, large sample assumption, d. Identify how you would obtain approximate values for any unknown quantities appearing in the confidence interval expression. In particular, provide a MATLAB or pseudocode. statisticsexamhelp.com. D. Program for any virtual experiment/Monte Carlo calculations that you would perform. If you cannot remember the exact name or syntax for a particular internal MATLAB function, such as expand or normed, just specify your own syntax and identify what the function does in words. Then include it in the appropriate place in your program. Alternatively, ask us. Solution. Function test, actual_data, %. This program will simulate replicates to determine the %sd, a hat, which is the unknown quantity in part C. % actual data vector is input as a function argument n equals length, actual_data, % number of data points per sample nrep equals 1000, a hat equals sqrt, a hat equals sqrt, 3, *std, actual_data, *std, actual_data, % estimate of a hat from the Sx of the data. % assume unknown true value of uniform distribution limit % is equal to a hat % generate nrep replicates from unifriend sim_data equals unifriend, a hat n nrep, % compute estimate for each replicate simahats equals sqrt, 3, *std, sim_data, % find standard deviation over estimate replicate stahat equals std, simahats. % That's all we need, so just plug in. statisticsexamhelp.com. Lower bound equals a hatstahat * Norman, 1 alpha/201, upper bound equals a hatstahat * Norman, alpha/201, return problem 4 consider